Chairperson. Today, I'm talking about a new approach to prevention of children falls from balconies using sensors. There are many accidents in Japan where children fall from the balcony. This graph shows the emergency of transport of children under the age of 5 due to falls from balconies in Tokyo from 2011 to 2015. As you can see, about 20 children fall from the balconies every year. There is a need to investigate how to use the balcony. So we collected photos of the balcony through the internet. As a result, we found out that there are objects such as flower pots, outdoor unit of air conditioning equipment, and garbage, tricycle, and so on are often placed in the balcony. Today, conventional preventive measures of the accidents for parents is to supervise their children's behavior and not to place objects that children climb on the balconies. But these strategies are not effective enough to prevent the accidents. Therefore, we developed a new system to help prevent children from falling from balconies by utilizing sensors. This system has two functions, a function for detecting a child and a function for evaluating environmental object shape. This slide shows the configuration of developed system. This system consists of RGB-D camera and server, a digital human child model, components for measuring human body, and environmental object shape, and components for estimating human age and for risks. I will explain the first function procedure of detecting a child. After setting a watching area, the system detects a person in that area and determines if the person is adult or child. Adult or child decision is determined by following algorithm. So when the system detects a person, the length of the torso is calculated by shoulder peak height and inseam height, and using a digital human child model, estimates the age from the length of this torso, and decide if it is a person is adult or a child. Next, I will explain the environmental evaluation function of the balcony. First, we set the watching area similarly to the function to detect a child. Second, detect the plane where the chime climbs. And third, calculate the probability that child can surmount the balcony railing from the plane. The system estimates the parameters of A to E using Kinect. The condition of the plane on which the chime climbs need to be parallel to the floor, as shown in this slide. In short, this plane and the floor is almost parallel. Then the plane detection algorithm detects 3 points located close to each other higher than the floor from point cloud data acquired by Kinect and creates the plane from the 3 points. Then compare the normal vectors of the plane and normal vectors of the floor and determine if it is parallel to the floor. Repeat this for the entire point cloud data acquired by Kinect. From the plane that detected, calculate the length and position of the side of the detected plane. We calculate the probability of a child falling from these plane data. The probability is a product of the probability that a child climbs onto an object and the probability to crossing a fence with an object as a foothold. These probabilities are clarified by past research. This example shows the simulation of climbable places and touchable places. Red indicates climbable places and yellow indicates touchable places. In case of 6 years old, 7 years old, like this, um, climbable places and touchable places depends on age. We use this digital human child model to calculate the probability of a child falling. Next, we conducted experiment of the balcony of living area of our lab. This is an experimental facility simulating such actual living environment. In the experiment, we compare the estimated probability by Kinect that a child summons the railing and the probability that a child summons the railing based on the actual dimension and position of a chair. The experimental conditions were from 0.1 to 0.25 meters from the chair to the fence. The result of the experiment is shown in this slide. This is an example for 1 year old. As you can see, the estimation and true values are almost the same. This means the estimated values by Kinect are accurate. Next, we conducted verification experiment on position and size of the plane used for estimating the probability that the child surmounts the railing. Here, we examine the length of the side and the area and the distance from the object from the fence. Let the size of the object measured with Kinect be measured value, and the dimensions of the object measured with measuring tape and ruler as true value, and compare these two values. The experimental result of this side length is shown. The error was within 5 centimeters, so measured value and true value are almost the same. We also conducted an experiment in real-world environment. The aim is to check whether the developed system would operated normally even under the influence of direct sunlight, wind, and electric lights. The experiments were carried out on the balcony of ordinary homes, and we operate the systems on the balcony for 24 hours, and we got position data of the people detected every minute. In this experiment, we could not detect only 2 minutes for 24 hours, so the detection rate was 99.9%. From this, we confirmed the system operates normally even under the influence of direct sunlight, wind, and electric lights. As a future work, we want to apply the developed technology to real children in real home environments. Let me summarize my presentation. In this research, we developed a new system to help prevent children from falling from balconies. The system has a function to detect a child in the balcony and a function to evaluate environment of the balcony. We confirm the effectiveness of the developed function by conducting experiments. Thank you for attention.